Example 1, divide negative 5x squared minus 8x plus x to the fourth plus 3 over x minus 3. We're dividing by x minus 3. So that goes outside the quotient bar. And we're dividing into this. And that goes underneath here. We have to put it in descending order of the variables though. So the highest power is x to the fourth. We're missing x cubed, so I'm going to put plus 0x cubed. You always want to include every power after the first power. So if the highest power is 4, every power less than that has to be accounted for. If one's missing, you put a 0 in just to hold space. Minus 5x squared, minus 8x, and plus 3 is the remainder of the problem. So every other power has been accounted for then. Fourth power, second power, first power constant. That cubic power is missing, so we put a 0x cubed in to hold its place. The division process will be step 1 to divide. So we take first thing divided by first thing. We keep it simple for the division step. So, and typically we're dividing by x, right? So all that happens is the power of x goes down by 1. So x to the fourth divided by x makes x cubed. It's positive x cubed. Make sure signs are accounted for in the division step. We're dividing a positive by a positive, we get a positive. We multiply the answer, whatever we get, times not just the first thing, but both things in the divisor. So we create binomials every time down here. X cubed times x is x to the fourth. X cubed times negative 3 is negative 3x cubed. Okay, up to this point, almost everybody gets them right every single time. At this moment is where people start messing up if they're not careful. Okay, the next step of long division is to subtract our product. Our product is this binomial. Subtracting a binomial is a matter of changing signs of both objects. So x to the fourth becomes negative, 3x cubed becomes positive. Both signs must change. Also, the word subtract is in your brain. So a lot of times people just subtract because they're thinking subtract. The decision to add or subtract is based on signs. These first objects should be opposite every time. X to the fourth minus x to the fourth cancels. These objects are whatever sign they are. You add or subtract based on the signs of the objects. In this case, 0 plus 3 makes 3. That 0 doesn't really do anything. Again, it was holding a place. It's not creating any difference. It just gets us the same object we got down here. The reason I put it there is because x cubed showed up. So I had a place to put it. I didn't put it underneath this and all of a sudden think that something was supposed to happen with those two things. I bring everything else down as is. So minus 5x squared minus 8x and plus 3 all move down. And we continue along and do the process again. The division process is just a repeating process. We keep doing this. Divide, then multiply, then change signs, then combine like terms, bring everything else down. Divide, multiply, change signs, combine like terms, bring everything else down. Keep doing this until this right here is just a number. 3x cubed divided by x is positive 3x squared. Every object after the first object has to have a plus or minus sign in front of it, so make sure that we do put pluses and minuses based on sign. This one's positive, so we put plus. 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. I get a product of two objects. I want to subtract that product, so I'm going to change both signs. 3x cubed becomes negative, 9x squared becomes positive. 3x cubed and minus 3x cubed cancels. This process always gets the first term to go away. The second term is whatever it is. In this case, the signs are opposite, so I actually do subtract this time. It's positive because 9 is bigger. Bring everything else down. Repeat the process again. Positive 4x squared divided by positive x makes positive 4x. We multiply 4x times x, we get 4x squared. We multiply 4x times negative 3, we get negative 12x. We're going to subtract, which is changing signs. So 4x squared becomes negative, 12x becomes positive. 4x squared and negative 4x being x squared being opposites cancel. Negative 8 and positive 12 opposite signs subtract. 12 is bigger, so it's positive 4x. Bring the next number down. Still not a number, so we got to keep dividing. 4x divided by x is positive 4. 4 times x is 4x. 4 times negative 3 is negative 12, or negative 12. We're supposed to subtract, which is changing signs. 4x becomes negative, 12 becomes positive. 4x minus 4x cancels. 3 plus 12, those are the same sign, so I add together, I get 15. Once I get a number, if this is x squared, once I get x to the first, if this is x cubed, once I get x squared, as long as the power in here is less than the power up here, you're done dividing. Okay, and as we get along in this class, we're going to start getting x squared and x cubed and x to the fourth being divided over in being the divisor. Whatever this power is, once you get one less than that power, you can't divide anymore. That's the remainder. The remainder is positive, so I put plus. Always put a sign there, plus or minus, depending on the sign of the remainder. And then the remainder value over the divisor to get your quotient. Alright, that is long division. That's how it's always been explained to you, by me at least. I don't know if anybody else has ever done polynomial division with you other than me, but that's how I always explain it. That's how it works. That's how you're supposed to do it. And again, this technique, anytime you're doing polynomial divided by polynomial, it works 100% of the time. Every single problem, it will work. Some of them aren't very pleasant to look at, but they always work. Alright? The other technique we're going to learn today, synthetic division, is not as workable. It doesn't work all the time. I'll tell you when it works and how you know it works, so you know when you can use it.